using. And Rohan, do you have Anaconda? Hi, Adarsh. Okay, fine, fine, Rohan. I think you can install. So everybody could install the Anaconda editor because this has a complete data science package in it. You don't have to install any other packages. And there's one more is there, PyCharm. So this would be helpful if you are in fact doing scripting and all. Anaconda is good for learning. So PyCharm is one of the most famous editor for Python. So both the links I have pasted, and we have a
We need to download both, sir. I mean, PyCharm and Anaconda both.
yeah. So I've given you the link. So probably you can download it afterwards because as
So, can we do it today by Jupyter Notebook? I have Jupyter Notebook right now.
yes, we'll be doing by Jupyter Notebook today. And if nobody has any editor, then I have one more link which I'll be sharing you right now, where you can do the hands-on coding. That would be your REPL. Okay, so everybody can see my screen. Uh, the screen. So if you don't have any editor as of now, I have pasted this link in the message box. You could use this for coding. We'll be doing some minimum amount of coding today. And coming to the site, we have so here whatever we do, right? So I'll be putting the videos here. For example, we are going to talk about installation or interactive mode and script mode. So I'll be putting the content, text content, and the videos here. After the class is end, I'm going to cut it down and then put it here. And then you have a quiz section here. So you could go and do the quiz. Are you able to see my screen? Right?
Yes.
So you could do the, for example, you could do the quiz like this. And there's a quite amount of quiz there. And then the explanation is also there with the quiz. And any other things we discuss, which is apart from this topic, that also would be created as a subtopic here. And the respective video, what that snapshot would be loaded here. But then at the end of the class, every session is being recorded. I'll send you the whole file for watching it, because it takes some time for me to cut and put it here. So let's just start with the Python. Okay, so why Python has become an essential tool for many programmers, engineers, researchers, and data scientists across academia and industry. So it's a near perfect fit for large types of problem, whether it's extracting meaning from large data sets, to scraping the data from anywhere on the web, munging data sources from the web, or automating day-to-day tasks and research tasks. Basically, in 1984, it started off, and a lot of researchers and a lot of it was open source from the starting. A lot of people were contributing to that open source, and hence it has a very rich set of libraries. For example, NumPy provides efficient storage and computation for multi-dimensional data arrays. It's something like whatever you could do with MATLAB. Rini, can you mute? Okay. Rini, can you mute yourself?
Yes, yes.
Okay. Like MATLAB, NumPy could do it very efficiently, can do it very efficiently, and it's predominantly used a lot in deep learning, machine learning, and also in data analytics. The library Pandas, which is used for data analytics, like Pandas is a library which can mimic your Excel sheet, or let's say any tabular data you have. So it could store your tables in the Pandas library, and you could do all the operations what you're able to do with the Excel sheet. And not only that, it's like database. If you are trying to query a database, and if you put a SQL query on a database, it's happening in the database side, right? So database might get overloaded, and it might slow down the thing. But Pandas, if you're going to use, you can load every table in the Pandas table objects, and then that could work in a cache, wherein you can get a speed up, and you don't have to really go to a database, wherein saving the network time. And then there you have a SciPy library, which is quite used by researchers for numerical integration and interpolation. Very rich set of libraries there with them. And then for visualization, Matplotlib, which is inspired from MATLAB style of visualization. And then you have a scikit-learn, which is where you have all the machine learning algorithms. There's a lot of automation which is done on the top of it. So your life becomes really simple if you are using scikit-learn. And we are talking about Jupyter Notebook, right? So Jupyter Notebook is the one which we are talking here, right? So Jupyter Notebook looks like this. So you could have a set of instructions which you can execute one at a time, and then also you could do some sort of a documentation, just like the way we have done a documentation. So it becomes a note. So researchers and academics, and also now industry people, use the Jupyter Notebook, which is this thing itself, for sharing their code with the inline notes also written about it, what exactly it is doing. So it's just not that, there's the code is there. So it becomes a very handy tool there. Then coming to Scrapy, right? It provides web scraping at a scale. Scrapy. So it's a framework wherein you just tell the set of URLs, and then it will go ahead and start scraping your web data and get it for you. And when we talk about AI, it is so important that in artificial intelligence that you have a data. So it works on data, right? So this helps you in getting the data. Coming to Selenium, which provides a web automation. So what happens in Selenium is like whatever browser operations which you do, right? So when you click on a browser, let's say whatever I do, I click on a browser, and then if I go here and if I click here, all these operations could be automated with Selenium. Quite handy tool. Like that, it goes on. There are rich set of libraries which is there with Python, and that is why Python is predominantly going ahead of other languages because of this reason. And why that is happening, because that there's a big open source community which keeps on providing these libraries, and very dynamic community as well. To start with, when we start a Python, we talk about what is a Python basically, right? So about it's a programming language, but is it just a programming language that if you know programming skills, if you know, is it going to solve your problem? No, it's like whatever problem solving you are doing, that problem solving has to be done before you should know what are the steps which is required to solve the problem. And then you will go to the programming part of it. So these go hand in hand. And the what is the knowledge concept? So let's say whichever field you are, probably let's say Rohan does analytics, right? So the knowledge of the concept is required, that whatever analytics is doing, Adarsh is doing, let's say he's working on researching, or let's say he's working on research on a 5G, right? 5G network. So he should know the knowledge about the 5G network, how exactly 5G works. So that knowledge concept is also very important, because at the end, the knowledge concept is what you're going to use in the programming. And then of course there's a problem solving everywhere, whether it is 5G, whether it's analytics, or whether any problems that you take for automation, right? So that problem solving is respective there, so that you need to be solving it, plus knowledge is required, and then programming skill also comes. So let's say so what are the topics that we will be covering? You got to represent the knowledge with the data structure. So what knowledge with the data structure we are talking about? Let's say I'll just take one example of a knowledge. So let's say you go to a knowledge. We are talking about retail. Everybody, all of us actually do shop on Amazon or Flipkart. And if you really see, let's say, let's look at Amazon. So can you see this? There's a cart here. Let's go and okay. So I think it's asking for this thing. But if you click on the cart, usually you'll get a list of items which you have actually purchased here. Okay, so there's a list of items there. So what a cart consists of? Shopping cart. If you have added, let's say you have added one mobile, and then you have taken, let's say, also one T-shirt. Okay, 1 second. Let's say you have taken one T-shirt and two toys you have taken. Okay. So what is this essentially? This is a list of items. It's a list. Okay, it's a list of item. What is there in the list of item? There is one integer out there. Could you see there's an integer here? There is an integer. And what is this mobile? So mobile, some brand mobile is there. The mobile brand is from LG, let's say. And some model name is there. Let's consider I am telling this as a string. Okay, and it's a list. First it is a list, and the list has an integer and a string here. So what is a data structure? What are we talking about data structure? What is a data? Is integer a data or not? It's a data, integer. A data, like it's telling how many numbers are there. What is a string? String is a sequence of characters. It's a sequence of characters. I'm sorry. Yeah. Okay. It's a sequence of character. So what's going on? What data structure are we talking about? As a shopping cart, this is a whole thing is a data structure. But inside the data structure, we are having a smaller data structures. Like integer is one smaller data structure. String is a sequence of character. So what is it? Smaller data structure is a character, but computer doesn't understand English alphabets. It is stored as a sequence of integers. We'll be coming to that. So essentially what we're trying to say that is you can represent a knowledge with a data structure. So what is a data structure? Where data structure is a place where you can store the data. So list is one data structure which could have a list of many items, and then that one many objects, and that one object has other object. Integer is one object, string is another object. So if you really look at shopping cart as an object, cart as an object is made up of list of other objects. Okay, and other objects which are inside it is made up of smaller other objects. To look at into it like this, what is universe? Universe is a one big object. What is universe made up of? Universe is made up of galaxies, a list of galaxies. Again, you see list of galaxies. What is galaxy made up of? So a galaxy is another object, right? As an object, what is galaxy made up of? Galaxy is made up of list of many stars and planets. And let's look at all these things. What are they made up of? They are made up of list of atoms. What is atom made up of? A list of protons, neutrons, right? So that list of object comes in everywhere in this nature. List of object, be it shopping cart or whatever. List of objects. A object is made up of other list of object. As we saw about universe and galaxies, planets, stars, atoms, we are also made up of many cells, list of cells. And what is our cells made of? List of molecules. And what is molecule made of? List of atoms. It goes on. That's this pattern, you cannot defy it, right? So here also a cart is made up of list of objects, whatever your products which you have purchased. But how many? And every object, what is it that every object consists of? How many items you have bought? So that is also an object, integer object. What you have bought? Some product you have bought. So we are representing that as a string right now. Of course, Amazon will be representing something as an ID basically. So what is that made up of? String. If you sequence of character, what is a sequence string made up of? String. What is string made of? Sequence of characters. And what is a character? Character become a smaller one, right? So somewhere we have to stop. Just like we stop at atom or neutrons or something like that. We need to stop somewhere in the data, and data also we stop at smaller objects which are integers, or let's say we will be looking at that smaller objects in data field. So that's how you represent knowledge, is represent data structures. So right now I need some questions like, did you understand how do you represent the knowledge as a data structure? So Adarsh, Rohan, Rini, any question? Shubham?
No.
Okay.
No question.
No questions, sir.
Okay. So kindly mute. Okay, fine. So iteration and recursion as a computational metaphor. So we will be looking at so there's something called iteration. That's like you go through each. So what is iteration? Iteration is like you have a list of object. So list of object exactly. Well, always remember this whole universe is made up of list of objects only. That's all. So you have a list of the same thing goes in programming. So list of objects are there. Let's say you have integers 2, 3, 4, 5, 6, 7. So you are iterating. What is iteration is like you take one element at a time, do some computation with it, then take another one, do some computation with it, and then that's called as iteration. And what is a recursion? So you will use for and while loop for doing it, for while loop for doing this. And what is recursion? Recursion is without using a for and while loop, you will do a function calling itself. It's a mathematical concept. Function calling itself. Function calling itself would be sort of a loop which is created, but then there should be a stop condition. Similarly, there is a stop condition here that as soon as you have retrieved 7, you stop. Similarly, a function calling itself, which is a recursion, has to stop somewhere. So we'll be learning about abstractions of procedures and data types. So what is abstractions? Abstraction, English meaning is ideas. Idea. Yeah.
Whether iteration and recursion are similar or related kind of thing, or both are two different things?
So in programming, iteration is telling that please to use for and while loop to take out the elements or like whatever steps you want to do. Whatever steps you are doing, that you can do using iteration. Uh, Whereas recursion would be a function calling itself. For example, let's take one example. Let's say you wanted to find a factorial. Okay, a factorial you want to find. A factorial of n factorial is nothing but 1 into 2 into 3, and that goes on till into n, right? So this is the problem which you need to solve, and let's look into how exactly you could solve it. As we said, look at the series. How do you solve it? You take one element at a time. It's a list of numbers, right? You take one element at a time, and then the operation of multiplication you're going to do here. Okay, so now this is iteration. So you're going to use for loop for, no, not for loop. Let's write the pseudo code. Take the element. You take one element at a time and do the operation of multiplication and keep accumulating it till you reach the end of your list. So that is iteration. And let's see what is recursion. So if I say factorial, can I say factorial of n equal to factorial n minus 1 into n? Can I write like this or not? Am I right?
Yes, sir.
Now this is recursion. You use a function to solve itself. And what will be this guy? This guy is factorial of n minus 2 into n minus 1, right? So since I have this formula is there with me, I'm not going to take out one element at a time. I'm going to whatever function I write, the coding, that same function I'll call itself. Function can call itself. That is the part of the programming we will learn. So function calling itself, and it's a two-liner code. Two-liner code. This is all I have to write into my function. That's all. But there should be stop condition. The stop condition would be factorial of 1 is 1. This is known to me. So this is known to me. Rest all would be taken care automatically. So this is a stop condition. So if I say factorial 10, it will internally call factorial 9 into 10. Factorial 9 internally will call which will get equivalent to factorial 8 into factorial 8 into 9. And at the last, you will go to factorial 2. You are going to find out that would be. So once we take an example, you will understand. But this is what recursion is.
Okay, sir.
What is the major difference means in iteration and recursion? Performance wise, you can do the task by both the ways, by looping also and by writing function also. So does it affect in the performance, or how to implement that?
Okay, Rohan, very good question. So what happens? Performance of iteration is better than the performance of recursion. It is better, but there are certain problems. If you start doing with iteration, it's very difficult to write, where recursion comes handy. Recursion solves it in very few lines of code. You cannot do it with iteration. It will become so difficult that you just cannot do it.
No, I agree to this point.
Yeah. So faster efficiency point of view, iteration is faster because function is going to call itself, right? So what happens is function takes its own space in a memory, and then another function is called again. Another function call happens. So again, another resource is taken in memory, which is your RAM, right? So it becomes a bit of a work for programming, and for the internals of the execution. So we have not seen that how exactly internally how it get executed. We'll have a look at that as well. So does that answer your question?
Yes.
So organize and modularize system using object classes and methods. So now if you really see a professional code, if it is not if it is haphazard, it becomes so difficult. The lakhs of lines of codes are there, and if you don't structure it properly, just go to a chemist shop, right? So how well structured it is. He knows this medicine, one particular set of medicine is here, and the other set of medicine is here. Of course, he's using indexing basically there, and he knows this category of medicine would be here, that other category of medicine would be there. So that is organized and very much modularized as well. So he knows that for a kids section, this module will have the kids section. For let's say for surgery related section, this module would be there. That's what has to be done in programming. Otherwise, it becomes so difficult to maintain, and that is like time is money, and if that something takes more time, it's a problem. So we will learn about organize and modularization using object classes and methods. So objects and classes are a sort of a encapsulation, which is like you modularizing in the chemist shop. If you really talk about it, it's one section. He has told it as encapsulating that, baby medicine, right? So similarly here also, we will create object classes to categorize like this set of this particular types of code would be inside this object. It's like you are encapsulating or you'll modularizing it basically. And that's how it is. Even the whole world also works like that only. Again, my favorite example is universe is encapsulating everything. Galaxy encapsulates certain sets of stars, and different galaxies are there. Andromeda galaxies encapsulates its own set of galaxies, and not galaxy stars, and Milky Way encapsulates. That's what encapsulation is. Encapsulate its own set of stars, right? So it's modularized. Even universe is so well modularized. So that's how we should be having it. And I will take one example of car manufacturing. It's so well modularized. One set of manufacturer produces tire, another one produces steering wheel, somebody produces engine, and engine also somebody who is producing, even he's getting objects of the engine like piston or whatever from somebody else. Like all these are objects, right? Everything is modularized. They don't make one full car at a time. It's not feasible, and it's not even possible to maintain it, because one thing goes wrong, throw the car away if you make one full car as a whole. But if you modularize it, then what happens? If a particular tire gets problem, replace the tire. If a spark plug gets a problem, replace the spark plug. It's something like that. So remember, whatever you see, and when it comes to programming, this is where people start failing, because they're not able to picturize that the real world, how the real world looks like as visualization. You got to start visualizing it that way. And same thing goes in your program also. It has to be structured in the same way, so that you see it's as object oriented, because nothing is visible to you, right? So you need to be visualizing it as objects interacting with each other. Different classes of algorithm, searching and sorting. So we will just have a glimpse of this different classes of algorithms, and searching, sorting, and complexity of algorithm. We will look a bit about it, not so much into it. This session is more on a Python coding and object oriented. But then certainly I will tell about the complexities of certain data structures. So let's come to what does a computer do. So computer in 1950s or 1940s is when they started doing it. And what came out was that there is a CPU, and it does some calculations. It can do billion calculations per second, and it can store the data. Okay, so one of the I'll still talk more about computers after this slide. And when it does billions of instructions, calculations per second. So how exactly it does it? So there is a recipe, a sequence of simple steps are there to be done. For example, if I want to make a tea, what are the steps involved? I take a container, I put water, half a cup of water, and then I'll put after boil it for 30 seconds. So look at it, boil it for 30 seconds. So there's a step involved, and then I wait for 30 seconds. And then after 30 seconds, let's say I'll put the tea leaves, and then again wait for probably 30 seconds. Let's say that's a step which is involved here. That's how I'm doing it. And then put the water, not put the milk, and then boil it for 2 minutes and put some essence, ginger or whatever, and then boil it. And then after another 2 minutes, I stop. There's a stop involved, right? And there's a flow of control there. And what was the flow of control? What steps were to take a container, put the water, and what was the flow of control? Flow of control was stop for 30 seconds till it boils. I am stopping. I'm not doing. I'm lying idle. Okay. And then after 30 seconds, then I take another step. So there's a flow of control also happening there. So this is one simple step and that's a recipe, and that's the recipe for everywhere, be it deep learning or analytics. You take pandas, and if you want to do some analytics on the top of it, so you have multiple rows, multiple data sets are there for different columns, and now you need the steps to either filter out based on some column data, or you need to pivot it. So there are certain steps involved out there, and those steps is what you will program to get the end result, and then you're going to stop somewhere. A simple algorithm would be 1 plus 2 plus 3. That's a simple algorithm. And in this, let's see what are the steps. Take a number 1, take another number 2, so second step, and then add them up. Whatever results you get, which is 3, you add it with another 3, and that's going to give you 6. It's a simple algorithm. There are multiple steps involved there. That's a recipe. So we know that the computers are the machines. So in front of you, whatever laptop you're sitting or the mobile, they are the machine, and they are examples of computers. So it's just not that, supercomputer or laptops. Even the watches is computer. Even your washing machine nowadays is computer, and also your microwave, fridge. Because there is certain set of programming is done and instructions are executed to get the results. For example, in washing machine, what is the result? There is a computer where you, on the top of it in the keyboard, you say that please work for 40 minutes. I need this normal washing. So it is pre-programmed to do it for 40 minutes, and it takes the water. There is a steps going on, right? So those whole steps are written, and the control flow is also there, and there is a stopping point which is after 43 minutes. It takes the water in, and then it starts rotating the drum at some speed. And after that, it releases the water, and then it spins, right, at certain other speed. So those are the steps which are programmed inside it. So how do you capture a recipe in a mechanical process? Either it could be fixed program computer, which is a calculator where it is at the hardware level it is done, or it could be stored program computer, and that's what we are here for. Different people use it for different things. Could be any task you want to automate using computers, you could be doing it. And that's what we are here for. Machine stores and executes the instructions. So you're going to store the instructions inside it. Let's look at the basic architecture of a machine. It has a memory. So that RAM which you have, 4 GB RAM, 8 GB RAM, or 16 GB RAM, this is what I'm talking about. And then you have a CPU. This is a CPU, which is i7 processor, probably AMD processor or i5 processor, or in the case of mobile, it would be Snapdragon from there's one company called Qualcomm, right? So these are the things. And in case of watches, it would be a microcontroller from companies like Qualcomm or anybody. Now, what does a CPU consist of? CPU consists of a control unit, and what were we talking about? Recipe, right? So it's all about computer. You give a set of instructions for it to execute. So what does it do? What else can it do? Program counter. It looks at it. The control unit has a program counter. It looks at which step I am executing right now. It keeps track of that. Okay, and that's all it does. But then execution of the steps. What is the execution of steps? What else the CPU can do? i7 or i5 does. It does only something called arithmetic logical units. Like it can add two numbers, subtract two numbers, divide two numbers, or it can find out logical unit, which is like whether it is a smaller, this 2 is smaller than 3 or 2 is bigger than 7, something like that it can do. And one more thing it can do is it take the data from an input and store it in memory, or take a data, do some operation on it, and send it to output. Right. So whatever I'm telling right now through a mic, my voice is going to the CPU, and so my voice is the data which goes to the CPU, and CPU, my program. What is the program which is running here? The program which is running is Google Meet, and that program is executing it, and it says that take Sumit's voice and and send it to the Google server, and whoever is connected to this meeting, send this voice to them. Right. So, and in my laptop, if you really see what program is running is the program which is running in CPU is this Google Meet software, which is taking my voice and sending it to the Google server. And from the Google server, it makes sure that the voice reaches you. And in your computer, what is happening is you are opened a Google Meet request. So whatever voice comes in, through the network. The CPU takes it and gives it to your speaker, and same thing goes when you speak. Same thing happens. So in fact, data goes in. CPU works on the data. It sends the data to somewhere else. Output memory. It can be anything, and some logical operations you do. That's all it does. Moving of data and some plus minus operation. So as we saw, input could be a mic, it could be a mouse, keyboard. Output could be output to a Wi-Fi network. It could be a speaker. It could be monitor. Right. So these are the output, and memory is a RAM. So any questions? Okay.
No.
And that's what we were talking about. A stored program computer have only these set of primitive things, nothing else. Arithmetic logic, simple test, and moving data. So why do we need a Python program as of now? Why Python program? So let's look at some architecture just to give you the hint of what's going on. Why a Python programming is needed. Earlier, when 1940s and 1950s, when computers were made, CPU, the computer scientists used to give the instruction in this format. There's something called as operation code, opcode. Opcode could be add, subtract. These are the operations, subtract, and usually depends on the opcode. There can be one or two operands. So in case of add, there are two operands. Operand 1 and then operand 2. So add 2 and 4, let's say. Or it could be subtract 4 and 2. So this is what the CPU understands. This is an instruction set of CPU. So this is one instruction. But try to understand, machine doesn't understand English, so it doesn't understand add in any case. So internally what happens, all the CPU maker, they have an operation code also as a numeric. So there is a mapping. So not mapping, rather it's a numeric. So let's say for add, opcode is 56. So internally, usually done 1950s, the computer scientists used to give 56 followed by 2 and 4, right? And this is what was the instruction set which was fed, and the CPU, when it saw that 56, it knows that it's going to add. But so happened that the computer certainly doesn't understand decimal numbers also. What does computers understand? It understands only binary number. So what is 56 equivalent of binary number? That we are going to put it here. 2 certainly I know right now is, let's say, this is 2, and what is 4? This is 4. So this is binary number. Whatever 56 is there, let's say whatever number. So what would be 56? It would be like 32 plus 20, 32 plus 24, 32 plus 24, right? So 32 plus 24. So yeah, so equivalent, whatever number comes here, right? 56. Just figure it out. So whatever binary number comes for 56, binary number for 2 and 4. And this was the instruction set which they were trying to give. It is so painful. Can you see this? A computer scientists were doing this during that time. So they said that let's have some sort of a automation where we will not give like this. Rather, let's give something at least like this. So that's where the assembly language came in. So they said that add, they used to write the code add 2, 4. So there was an assembler. So assembler took this code and converted it into machine language. And this is an instruction to the CPU. This is one instruction. So this one instruction, CPU runs it. It gives it to the ALU, the arithmetic logical unit, and then it tries to execute it. Well, so this is also not that great, right? So somehow they said that let's have something like English language, the way I'm talking to you, something like that. Can we create an interface to a computer so that somebody can at least easy for us to program? Even this is so difficult, right? So they said, okay, let's do some other automation, and that's where high-level languages like C. I will not call fully high-level language. C language came in, and then C++, Java, and Python. So it's all about making it an English level interface to the machine. That's all. That's why it's called as Python language, high level language. Python language, right, is one sort form of a high level language where you tell in English, and that has to be converted to this guy, right? So before converting, first of all, what happens? Whatever language it is, C, C++, or Python, there is a converter. I will say generic term converter right now. The converter will convert first to assembly language, and then from assembly language it will go to machine language, right? So in fact, conversion step is simple. Whatever you are telling, convert it to machine language. However you do it, that's a conversion, right? It could be to, first of all, assembly language. From assembly language to machine language, it's okay, it doesn't matter. But then converters are of two types: interpreter and compiler. So C and C++ is compiler converter, and Python is an interpreter. So what's the difference between a interpreter and compiler? Compiler takes, let's say, compiler takes all 100 lines of code, and converts it into machine language at one shot, all the 100 lines. And then only you can execute it. It gives you an exe file. That exe file is nothing but having this. These instruction sets are there in the exe file. So that exe file is for all the 100 lines. So only after you compile it, then only you can execute it. So right now, when you click on the Chrome browser or whichever browser, that exe is getting loaded into a memory, which is nothing but this set of instructions. Okay. But what does interpreter do? That's also another form of converter which Python uses. That takes only one line at a time. That's the only difference. It takes one line at a time, converts it into a machine language, sends it to the CPU to execute. So this guy is interactive in nature. Interpreter is interactive in nature because you can do one line at a time. Compiler is not interactive in nature. So what do I mean by interactive in nature? So let's look into that. So in Jupyter Notebook, you can create a Python 3. There's a Python 3 interpreter is there. So when I say interactive 2 plus 3, if I shift enter, execute, so one line is, this is one statement which Python as a high level language converted into a machine language and sent it to the CPU. But it did it for only one line. But this you couldn't do in C language or C++. First you have to compile, get the exe, and then run the exe. So that's the difference between interpreter and compiler. Any questions, Rohan, Adarsh, Rini?
No, sir.
Okay. Okay. So programming language provides a set of primitives. So we want to create a recipe, right? So how do we create a recipe? So it provides a set of primitive operations, and those primitive operations are multiplication, plus, minus. This is what it could be, because the computer is, in a sense, you wanted to abstract the mathematical operations, right? So once you abstract the mathematical operations, the operators also which you are used to communicate with the computer would be mathematical operators only. If you really look into this is what I was communicating, 2 plus 3, right? So I am using, this is the operator. So these set of operators are provided by Python for you to, in fact, so these are, for example, arithmetic operations. So it has plus, minus, star, divide. We will look into this more. But just to say that programming language provides a set of primitive operations. And expressions are complex, but legal combination of primitives in a programming language. So what is the expression? In this example, this is the expression. You can have a star 5 is also an expression. These are all expressions. And expression and computation have values and meaning in a programming language. So they have a value. So this expression, when I executed, it had a value. So what are the aspects of programming language? Let's look at a language called English. What is internals of English? It consists of words and the grammar. These are the English language words. And this is how I'm communicating with you right now. And we have been taught the grammar so much, and we have listened so many people talk. We know how to talk about it. And somehow we do go grammatically wrong, certainly, and then it doesn't make sense, right? Similarly, programming language has similar set of construct for talking to computers, and they are nothing but mathematical operator, as we said. Why? Because computer was made for was abstraction for the mathematical operations, right? It was the idea behind doing mathematics. So you have those mathematical operators here. So these are the operators: less than, bigger than, star is a multiplication, slash is a divide, equal to for finding the comparison whether they are equal or not. Plus, as I said, English has alphabets. That's what we were taught. As soon as we went to school, we were taught about alphabets, A, B, C, D, and that's what these words are made up of. And then programming, it's a data types which it is made up of, because you're not seeing anything, right? So it's a data which is defining. A shopping cart was defined by data only, right? A list of objects, and the objects were a list of integers and strings, as we could see that, right? So it's invisible, right? So it's a data type which is going to represent your objects. And at the elementary level, the objects could be represented by float, integers, and there's one more special type called Boolean, which is true and false. We will look at this. But then, as we said, computer was the abstraction of maths. What else data types will you have? Here it is like letters, right? What else you'll have? You will have really the basic elements. Just like here, alphabets are the basic elements. Here you will have the data types. Basic elements will be float, integers. That's all it could be, right? Of course, we will see that strings could be created out of, though it's written string here, strings are created out of integers. It's a sequence of integers. These are the only data types you have. Of course, you can create a complex data types using a simple data types. So aspects of the language. Let's say in English syntax, cat, dog, boy. It doesn't make sense. Similarly, in a programming, you have objects. We start thinking about objects. This is a string object and this is an integer object. The string and integer object you are just placing together. What are you doing with that? I have not even told it. So what will computer do with that? Nothing. The operation I have not told. So it is a syntax error in this case. So the programming language have its own syntax. If you don't write it correctly, what operation could be performed between two objects or three objects, then it is going to throw an error. Similarly to English, it doesn't make sense, these set of words. What does that? Cat, dog, boy. But cat hugs a boy? Yeah, it's syntactically valid. Here, I'm having two objects and I'm multiplying them. Similarly, the semantic errors are also possible in the English language, like I are hungry. So first of all, I'm telling I am a single person and R is many person, many people. It doesn't, it's syntactically valid, but its semantic error is there, right? Grammatical error, what we call as grammatical error. In programming language also, you could have a static semantic error similar to you're adding an integer with a string. So similar to that, you could be doing some operation on the two objects, but they are unrelated object. It doesn't make sense. Like, what is the use of adding a 3 to high? It doesn't make sense, right? And lastly, there is something called as, programming error. So in programming error, what happens is you wanted to say something to the computer to do, and but then you intended, but you wrote something else, which is what we are learning here right now. That's how do you program, right? So if you don't write program correctly, if you don't know how to convey to the computer what to do, that would be a logical error, which will end up in program crashing, stopping, and giving unexpected results, which you never desired. As so Python language could be executed in shell or as a script, which is in a file. So let's look at one of the example. If you open a terminal, if your Python is installed in your computer, if you go to command, if you have Windows, and if you go to command and if you write Python there, then you will get a Python shell. And then if you write 2 plus 3, see, this interpreter is working one line at a time, it is executing it. So this is called as shell. You directly run it in the shell. So this is called Python shell. Even though Jupyter Notebook is also something like that, it's a hybrid of it. So it acts as a shell, as well as I can also have multiple statements. So in Python, if you write print 2 plus 3, you print to the output. I could write multiple statements as well. 5 plus, and then print 4 divided by 5. So I can do all of them. You could see that. So I have multiple statements which is getting executed, which is like it's a hybrid of script as well as shell. What do you mean by script? Script is like, as we saw here, this is a shell mode, one line at a time. Script would be something like this. So if I say Python, I have one program already listed. So this is one program, hello world, print 2 plus 3 and print 4 by 2. And if I go ahead and write Python, so file name could be anything. In this case, it's Python 1. I write it, it will execute and it will give all the values, whatever we saw, right? So this is called a script mode. And this is what would be, this is what you would be running most of the time in your production code, where a human intervention is not required. And this is what ideally you should be moving towards, scripting, right? But then for learning purpose, you could be doing it in Jupyter and or the on the shell side. But sometimes I don't even I don't write script. I have my code in Jupyter itself, and through Jupyter itself, I have a set of lines of code here doing one task and another set of lines of code doing another task. I just execute this and then execute that, and my results are coming. But ideally, that is not which should be happened in production. But suppose you want to do some sort of an analytics, right? So, and you have a Excel sheet with you, and then you just load the data, and you want to do some sort of a mapping of aggregation of data with respect to one category, right? So you could just do it in Jupyter Notebook itself. You don't need a script as such. But then if you want to do automate it, then you need a script. So let's look into objects, and it's a very important concept. I've been telling many times, and we have taken example also when we saw the shopping cart, like objects, and also about universe or anything else. Everything is object, and we should be looking at program manipulates the data objects. When we say data objects, in the case of in the case of shopping cart, when we saw what were the data objects, so data objects was it's a list of products which you have bought, right? And every product is consisting of what product is there and what count of product you have bought. Like for example, mobile itself, what was the count of mobile? And programming is all about manipulating that, right? At the end, the cart is going to give it once you have the products in your cart, right? One mobile, one T-shirt, and let's say two toys were there, right? Of different types of toys were there. You need to find the total of it, right? So what you will do, you will look into mobile. What is the price of the mobile for one count? Then you will look into what is the price of the T-shirt for one count, and then toys. What is the price of the toys, whichever you bought, toy one, toy two, right? What is the price, and you total it, right? So, in fact, programming is a manipulation of data objects. What else can you have in computer? You can have only data objects, right? And also remember that different types of object, you cannot do all the operation with different types of object. It's something like what we saw here, that 3 is an integer and the string is another object. This operation doesn't make sense. So that is also very important. So coming to the different types of object is a scalar object, which cannot be subdivided. In Python, we will see what are those scalar objects, and the non-scalar object, which have an internal structure that can be accessed. So the shopping cart was a non-scalar object. It has an internal structure, and the internal structure where that the count of the product was made up of. First of all, it was a list of products, and every product was actually made up of was a string defining what product it is, which is like string, and then what is the count of product you bought, right? And there's a price also associated with it. So it's a non-scalar object, shopping cart, which has an internal structure, and we saw what is the internal structure. First, it's a list, and followed by a string and the number of quantity you bought, right? Whereas scalar is like you cannot subdivide. An example of scalar is integer. 5 is 5. You cannot do anything with that. It means just 5 or 4. It's an integer, right? You cannot subdivide it. Similarly, floats are representing your real number. You cannot still subdivide a real number. And Boolean is a true and false, yes or no. Here we say true and false. It's a special data type. Again, cannot subdivide it. And there is one more none type. is a type of object which has only one value in Python. None. Nothing else. None. None says that I don't have anything right now. And since if you don't know what's the value of a particular variable, when you start your programming, then you assign it to none. For example, if you go for collecting data, and the data if you have collected, and suppose you were collecting data as a population of different areas in Bangalore, and let's say you don't know particular areas, you have not collected the data, so you're going to put it at none because you don't know what is it, which has a special meaning saying that I don't know. Can use type to see the type of an object. So how do you see a particular type of an object? So as we are talking about in Python, it's all about data types. So how do you see a type of an object? So we use type function, which is internal to the Python for doing it. What is a function? So if you really see, function is mathematical function. What do you say? X, y equal to f of x. F is a function. It takes one parameter x. It could take one parameter and it gives the output, right? So similarly, the same concept goes in Python also. The function is, a name is given. It has to take some parameter, and it will going to give you output. See, y is equal to f of x when you say mathematics, if you say y equal to f of x. So, and if this f of x is nothing but is a function is x square. So if the x value is 2, which I'm sending to this function, the output of this function is going to be 4, right? So function takes an input and provides the output. That's how you got to look into a programming function also. So this type is a function which takes an input and provides an output. And what type of output? That's what we are going to look into it. So it takes a data object, 5. Let's say if I give any object I could give. So let's take one example. I write type type. So I think others can also start doing it. So do you have this one? So I want you to in fact open this REPL. If you have editor, it's fine. But if you don't have the editor, use this. Others, do you have any editor? If you don't have it, then use REPL IT. And
Yes, sir. I am using notebook.
Okay.
Jupyter.
Okay. And how about Shubham? Do you have the editor?
I am using one notebook. Jupyter notebook.
Great. So I think you could in fact do this. Give a integer object type 4. You see integer is coming, right? So it's telling it's an integer object. Yeah. Please unmute. Please mute. And similarly, if you write type 4.5, so please execute and see integer and a float. These are the type of the object. And remember, this is important. Float is another function. We are going to use it. Float function is there. Integer function is there. As many different types of object is there. There is a respective function out there for type conversion. We are going to look into that. Just type and use something like this, hello, in single quotes. You'll see string object. Again, there's a function with this str. We will see this. But what is it? What does it tells you? It takes an input of a particular object, any object it could be, and it gives you the type of the object. So let's come to type conversion. We were talking about functions. And once we say a function is this thing, I mean, function is a mathematical jargon. But what exactly is a function? It's nothing but a transformer, basically. It transforms. It's a mathematical jargon, but it is a transformer. What does it transform? In mathematics, it transforms, it takes a number and gives a new number. That's all. Function as a transformer takes a number and gives a new number after transforming it. after scaling it, probably multiplying, dividing, or whatever it is. In this case, it has scaled. It has taken 2 as input, and a scaled version of that 2 is given as 4. So it transforms a number. Similarly, type conversion, which is casting, we have a float function. What does float function takes? It takes an input and it transforms it. What input does it takes? It could be anything. If you give an integer, it will transform it to float. If you give a string, it will try to transform to float if it is possible. Similarly, integer function, it takes an input, could be anything, string or float or whatever, and tries to transform to integer. And let's try to see the example now. So let's try to take integer. We want to convert the float number 4.5 to integer. So look at it. It has converted to 4 because it will truncate the 0.5, but it has actually converted to integer. And we could see the type, pype type int. If I try to see, we could see that it has converted to integer. So you could be typing this program as well. If I write float, let's say integer itself, I want to do integer, and let's try to give 45 as a 45 is a string, right? If I do it, it has converted into 45. So we could go and look into the type, whatever is the type, right or not right now. But as a whole, 45 is a string. Remember? We go and see 45 is a string, but after typecasting, it has become a integer. But what if I want to convert 45a, a string called 45a to integer? It will not allow, because it says that invalid literal for integer with base 10. It tries to convert any string which is having digits to a base 10 integer. And it is trying to tell that a doesn't belong to a valid digit for a base 10. So that's a typecasting. You could be typecasting to anything, and also string. Probably if you have an integer, let's say I have an integer 45. If I want to convert to string, you will do str. This is going to give you, see, there's a single quote. So the single quotes around any set of character, it becomes a string. We will be looking string in more detail. We'll be using a lot many time casting. So if you have any questions, you can please ask me. And have you executed it?
So I have one clarification. We cannot convert any string value to an integer. Like 45a was a string, we cannot convert it into any other string or boolean.
Yeah, so you cannot convert a string having a non-digit character, non-digit to a integer. Why? Because a is not an integer digit.
Okay. Any non-digit cannot be converted into other than string. I mean, into integer or into boolean.
Yes, so it goes like this. See, it tries to convert it, but then int is telling that I need a decimal number is from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's a decimal number. It can have only 10 characters, 10 digits. So it says I don't recognize a, so I cannot convert it.
If instead of a it was a boolean value, then
Instead of a, if it was a boolean value. Okay, so well, a string is string. So boolean cannot be there here, but as it is, if you want to have something like true is a boolean value, right? So this will work.
Yeah.
This will work. Yeah.
This will work. Okay.
Yeah. So this would be converted into this would be converted into 1.
Okay. Okay. Boolean value will be converted into 1. Okay.
False would be converted into 0.
False will be converted. Okay. Okay.
So well, integer is a function. So what is a function? Function is a set of steps. Function is a set of steps. When I say x square is a step which says x into x. It's a star, right? Star x. So this is step. which is multiplying these two numbers, x square, right? So this was a function here. So integer by itself is a function which is a set of statements would be written for it. And whoever has written Python, they have given this interface that integer will do this. If you would have written Python, then you could have written something else also, right? So it depends on you. But then they have written logically what actually integer could be converted, right? So false and true to 1 and 0 is their construct, and it makes sense also.
Okay.
Now, how do you print to a console? You're going to use a print function. Again, it's a function. A function takes input, and it's not just that a function can take only one input. Even mathematical functions takes multiple inputs. Similarly, a function here in Python is the same thing, same thing, which can take multiple inputs. Here we have taken one input, 3 plus 2. So what happens in this case? Whenever compiler, the interpreter sees this, it goes and first executes this expression. Once it executes this expression, the output of this expression is 5. 5 is sent to the print, and print as a function which has a set of instructions there will make sure that it is printed to the console, which is nothing but your monitor. So we have already looked into expressions, but then again, coming back to it, expression combines the object and operators. So, the objects we have come to know till now, the scalar objects we have come to know. The scalar objects are integer, float. Can anybody tell me what are the other two scalar objects in Python? Integer, float.
Boolean string.
Boolean and string.
String.
Boolean is right. I mean, you can say string, but then I don't consider string as a scalar. I'll tell you why. First, scalar is the one which you cannot subdivide it. Though in Python you will say that string cannot be subdivided, but then looking at it further into it, strings are made up of sequence of integers. Yeah, computer doesn't understand letters, right? It understands only integers or float representation. So this none type is also there. I think we just saw this none type. Okay, which says that I don't know what's the value. It's a placeholder for whatever is not captured. It's a scalar type. Since we have already come to strings, let's look into what the string is made up of. Okay, so let's say a string, right? So I have a string hello. Now suppose you were told that computers don't understand H. It really doesn't understand. You and me understand because somebody has always told that this is H. And the sound is like phonics. H, E, vowel. E looks like this. So we have understood by visual. So computer doesn't have all these visual capacity. Doesn't have that intelligence. As of now, it has it. That's a different thing. Computer vision can do this. But then if you wanted to, because computer doesn't understand alphabets in any case, so what mechanism would you come up with so that computer understands it? And can you look at the pattern? It's a sequence of characters. And what are the characters? H, E, L, L, O. And there is a pattern. There is an order to it. It's not that I can write O, E, L, H, L, right? So this doesn't become hello. It has a pattern. So it is ordered list of characters. But how do you convert to a number? Can anybody tell a scheme? I think Adarsh and
Yes, sir. Based on the ASCII value.
okay. So ASCII value would be one of the, what is ASCII value? So the ASCII, when you say that's a solution you're telling, I'm talking about the idea. That's already existed. But what is the idea behind ASCII values?
So as it is a computer understands numbers. Every letter which you type on the keyboard is associated with one particular number.
Perfect. Very
ASCII, ASCII is that list.
Yeah.
That list of numbers.
Right. And so that's a mapping it's a mapping between the letter and the number. Right. So that's a concept. Mapping between the letter, character, or whatever it is. We call it as character to the number. Okay. So to the number. But how many values can ASCII do it? ASCII has how many bits? 8 bits. Eight bits can store 256 numbers. Right now, we have Chinese, Telugu, Malayalam, Tamil, French, Japanese. So many characters are there. Python used to use ASCII when it started, but right now it doesn't use ASCII. So, Rini, are you aware of binary numbers? Do you have any doubts? Shall I give you a refresher on binary numbers?
Yeah, I was going to ask this only. If you can explain in brief about ASCII or the binary numbers.
Okay, so look at it like this. So till now in our school we have been taught decimal numbers. 23 is, what is 23? Why it is 23? Because this is a units place. Am I right?
Yeah,
This is 10th place.
yeah,
If I put 1 here, then this is hundreds place.
yes,
But where is it coming from? It's coming from, because it's a decimal number, 10 digits are there. So first of all, 10 comes. Then you
yeah,
put 10 to the power of 0, which is 1. Okay.
yeah,
This is the 0th position. This is the first position. 10 to the power of 1. 10th place. This is the second position. 10 to the power of 2. 100. Got it?
yeah,
So you do 3 into 1 plus 2 into 10. It becomes 23. Plus 1 into 100. 123. Got it?
yes,
Let's see, in binary number, there are only 2 digits. 1 and 0. That's all you can have. Nothing else. Here in the decimal, you can have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. In binary, you can have only 2 digits, 1 and 0. Right?
yeah, yeah,
So let's say I represent this number. Can you tell me what is it? This is 2 to the power of 0. So because 2 is there, right? So this was 10, this was 2. This is 2 to the power of 1. And this is 2 to the power of 0. And multiply them. 0 into 2 to the power of 0 is 1. 1 into 0 is 0. Plus 1 into 2 to the power of 1, which is 2, which is 2. And this is 0 as such. So this value is 2 in binary numbers. Okay.
okay,
Similarly, if you have 8 bits, so I have 8 bits here. Look at this. So what does this represent? This is 2 to the power of 0, and this is 2 to the power of 7. So what is the value of this number? 2 to the power of 7 is 128 into 1. So this is 128. Got it?
yeah,
If you put all of them as 1, it comes to be 255. If you put all of them as 1, it comes to 255. And of course, the 0 number is also there, so you can represent 256 numbers using 8 bits. Got it?
okay,
So 256 numbers you can represent with 8 bits, and ASCII is 8 bits. So what the Python developers thought, let's use Unicode. There is a Unicode is there, and that Unicode has many format. They use 20 bits Unicodes. What is it? 20 bits. And 2 to the power of 20 is 1 million. Approximately 1 million. Okay. So now you can have 1 million characters. And what type of Unicode usually internally uses is UTF-8. You will see once you do a string operation, right, Rohan, you will see a lot of places, right? So UTF-8 would be used for encoding and decoding the strings if it is there in the Excel sheet. So UTF-8 is it's one of the construct. I will not go deep into it, but then it's a 20-bit is what is used now. Okay, so ASCII was earlier used, but then a string is a sequence of characters, and when you use a sequence of characters, the mapping is nothing but then you remember Unicode retains the ASCII value code. Whatever ASCII value code you had, it retains it. Same whatever was in ASCII in Unicode also, those set of numbers are represented as that. For example, A is represented as 65. And we will look into it. You can code it in fact. So how do you look at it? You have one function for doing it, and that function is called as ORD. ORD, and give a character. You will see it will give you 65. So it's an ordinal value. B you
so
will
it
write.
is already feed it inside. I just need to keep on finding using ORD function.
I mean, like if you're doing anything manipulation with integers, right? That time, if you want to know what is the character equivalent integer, then you need to use it.
Okay.
Sometimes it is required while understanding what is a string, but otherwise you don't need to do it. But what we were trying to tell is, I'm trying to tell string is not a scalar is not a scalar object.
Scalar object, yeah.
It's a non-scalar object for me. Though people say that string is one of the scalars inbuilt data type, but then I don't see that because it's a list of characters, which is nothing but a made up of list of integers. Okay.
So I found a table of ASCII value. The table needs to be referred in future, or it is already there in Python and we need to
It's a standard
insert it.
format. It's a standard
Yeah.
format. Python follows it. Python follows that. It's all over the world. Every programming language has the same thing.
Okay.
It's not Python specific.
Okay.
So you combine the objects and operators to form an expression. So these objects are there. So we saw that different types of objects could be there, and of course the objects could be, for example, you take an object 1, an object 2, and do some operation on it. So this is what we did: 2 plus 3, right? So 2 is one object and 3 is another object plus. What about if I do cart object? I could have, I don't have a user defined cart object here, but at least I can have operation like this. Hello is a string object, and I do plus with this. So it concatenates it. So it gave me a new object. Object 1, operator, and new so you got to look at it. Everything in programming is consist of this. This is all programming is all about. You have statements like this: objects on object. You're doing some operation on the object. This is a simple one. What about if I have a cart object? Cart 1 plus cart 2. Two carts were there with me. Okay. So what would it give me? So cart 1 had 5 products which I bought, and cart 2 had different 3 products which I have bought. I'm going to buy. If I do cart 1 plus cart 2, it will give me 8 products inside it. Okay. So that's how programming works there. So if you are in the field of, let's say, research 5G, 5G network, you know, the waves are coming. So you have one wave coming from there. So you have one wave object. The another wave time series wave object is there. If you do some operation on it, probably you're dividing or you're adding it up, you get a new object which will have the concatenated of two time series waves. Okay. So that's how you will be looking at there. Expressions. So these are the expressions on which you do it. Operators on ints and floats. I plus j. So different types of objects are there. Like say if it is both are integer, then output of this is also going to be integer. But if any one of them is a float, then whatever operation you do, integer plus float, it's always going to be float. For these 3 operators: plus, minus, and multiplication. But for division, it's always a float, irrespective whatever it is. So you could do some examples here and check that this concept is quite important right now. 4 by 3 is going to give me 1.3, and 4 by 4 is not going to give me 1. It's going to give me 1.0. Suppose you wanted an integer, then you need to do double divide. Now it will give you an integer. This is used many places. While using while loop or for loop, you need an integer. Why? Because while and for loop can only loop for integer times. It cannot loop for floating types. So you need to use these type of operators to get integer values. This is one of the confusing factors. So you should know these 2 things. Just execute there and check and get a hang of it. And then if you do T plus 4.0, it's going to be 7.0. I mod j. I mean, this one is used a lot in logical operations. So let's say you say 4 mod 2 is going to give me a modulus operator. its modulo operator. It's going to give me a reminder. So 4 mod 2 is 2 divided 2 into 2 is 4, and so reminder is 0. What about if I say 5 mod 2? It's going to give me 1. So these are used for finding odd and even numbers. If you use any number mod 2, and if it is 0, that means it is an even number, and if it is not a 0, then it is an odd number. How do you take a power of a particular power of a digit, like 2 to the power of 3 if you want to do? So you're going to write 2 star star 3 8. So any power could be done with this. So and then like 4 to the power of 0.5 will give you square root. Okay, so and so you could do any of it. Cube root also could be done. So 4 to the power of 1 by 3 is cube root. In any doubts?
No.
Okay. Simple operations. Parentheses are used to tell Python to do these operations first. So let's come to the operators in Python first, and then we will look into this. So the different types of operators what Python has is arithmetic operators. We have just looked into plus, minus, star. These are very evident. This is our only one floor division, we call it. Modulus. This is a negation, which is like whatever number you have, let's say 2 you have, you put minus, then it becomes minus 2. This is not used plus. It doesn't make sense to be used. So that's your arithmetic operators. Most of them take 2 operands. This one is the only one which takes only 1 operand. In Python, integers could be any length. So there is no limit for the integer length. For example, you could see that I have multiplied these 2 integers and I got this value. Some of the programming language, depending on the number of bits you have in your register, 128-bit or 64-bit registers or computers, you will have a range of integers which you can have. But in Python, it's not the case. So in arithmetic operation, when you do addition and subtraction and multiplication, so this becomes an expression, and you want to give a precedence that don't do multiplication as a higher precedence than plus and minus. So you could use a bracket to do that. So that's what we are trying to tell here. Look at the precedence of the operator. The bracket takes the highest precedence. And when you see star, multiplication and division has a higher precedence, plus and minus. But if you wanted to do plus and minus before this thing, you could use parentheses for doing that. We have already seen these 2 things. Bitwise operation we are not going to cover because we rarely use. Probably, I think Adarsh and you might be using bitwise operators, right? I'm not sure about it. No, I don't think so. Usually it is used in networks and all at the bit level, once you want to do the operation on the bit level. So Adarsh, if you want to cover it, we will cover it separately for you, right? For bitwise operator. Do you want me to cover? Because right now I'm not going to cover that. But I'll give you an overview of it.
No, sir, you can do. Means no problem, sir. We'll see later, sir. You cover based on yours.
Okay. So bitwise operator would be, as we were talking, Rini and Rohan, we were talking about this, right? So bits. So bitwise operator actually goes to the bit level and you have bits, right? So 0, there are 2 numbers. So you start manipulating at the bit level, which is done by network engineer most of the time. We don't do it because in our analytics or Python automation, I have never used it. In fact, bitwise operator, I have been working since 20 years. I did not work in network and I have never used ever in my life. So that's why I don't want to even tell you. So you, basically what does it say? The ANDing of the bits. So what will be? So if you say this is A and if you say this is B, if you AND them, if you do AND, bitwise AND, it's like doing bitwise AND of this. So, and what is AND basically? If I say, please give, I am satisfied only if you give me both apple and bananas. I want apple as well as banana, then only I am satisfied. So satisfaction means either I'm satisfied or not satisfied, right? So 0 means unsatisfied, 1 means satisfied. So and operation is similar. 1 and 0 would be 0. Why? Because 1 and 1 will only be 1. So it's like 0 and 1 is also 0, and 1 and 0 is 0 and 0. So A and B would be 0. That's a bitwise operation. But if it was somehow if it was or is given like this operation, you could see this. This is or, bitwise or. It's like or means give me apple or banana. I'm satisfied. Either one of them. So this is 1 and 0. So this will become 1. 0 and 1 is also 1. 1 and 0 is also 1, and 0 is 0, because neither you have banana, neither you have apple. So I'm not satisfied. Either one was satisfied with me, right? So that's the meaning behind it, and we don't do it usually. And this is shifting of the operators. Like you can shift the binary digits. From, for example, 1 0 0 is there, and if this was your A, and if you do A shift 1, that means this number will become, you will shift it right, left, so it will become 1 0 0. That's all it is. It has its own mathematical meaning behind it, which does the operation very speed, which has very good speed. Suppose you had a number, right? So decimal number, if you write bin function, you'll get a binary number out of it. So how a binary number is represented internally, we will be looking at string literal, integer literal. That time we will see this. Now coming to very important operator, assignment operation. We have seen that variables can be assigned with the equal to operator and the value stored for a later use. Right, so always we do right now, we take a variable and we do assignment. So what does assignment doing internally? It actually assigns yeah, tell me, any question?
No. Just this. It assigns a value to a variable. So 24 is the value for A.
So internally, what is happening? Internals.
So internally, it is when we are giving a command of print, we are calling 24 assignment through A.
Actually, it is storing this value to some address, and whenever we are calling, so it is giving us that from that address part.
Yeah. So yes, rightly said. And Python is a bit different. We will see that now, and there is a knowledge required there. So we will take one example right now and see how exactly it is different than C and C++. So this assignment exactly does what you said, that in memory address, it goes and stores it. There is a bit of a difference here than C, because in C language, that's what happens. Here we will see what happens there. You could use something in the assignment operators, any operator like plus equal to 2, it is in nothing but equivalent to A equal to A plus 2. You could have it like for any of the operators. Minus A minus equal to B is nothing but A equal to A minus B. A star equal to B is nothing but A equal to A star B. For any of the arithmetic operators or logical operators, the same thing goes. Not logical, bitwise operator. No. Then there's a comparison operator. We will when we come to if, we will be looking this in depth in any case. But this is nothing but it gives you output as true and false. So Boolean. So Boolean can, because Boolean, a lot of people have problems. I want you to declare a Boolean variable. Can you assign a Boolean? Can you create a Boolean variable? all of you, just go ahead and take a. Come on, can you create a Boolean variable? And after creating the variable, you need to type. You need to find the type of the variable. Do assignment. Take a variable name and assign it to a value, so that that variable becomes a Boolean. Can you do on that example? And check if you are able to do that, and tell me if there's a issues there. So were you able to create the Boolean variable?
For creating, we will take bool, that BOOL, and then a equals to something like that.
Okay, so like how do I create an integer? I'll show you. So when I create an integer, I take a equal to 5. So look at it. Python is a dynamically typed language. So here, the type is inferred from the value, and that's the difference I was trying to tell you. Here, it's not like in C++, you'll write int a equal to 5, right? But here it's not like this. Here, a equal to 5. It says that 5 is an integer, so a becomes an integer. Then if I write type a, it is going to give me integer. So this is my integer. What about float? Let's say f equal to 3.4 pyp type f float. I want something like that. Can you create a Boolean variable? Whatever you're trying to tell, even that works out. But
So I'll print whether A is equal to 5 or greater than 5. That will give me a Boolean value, whether it is true or false.
it will give you a Boolean value, right? I want you to create a simple Boolean variable. Yeah, that's really good answer. That's fine. But can you create a Boolean variable like this? So what are the Boolean values? See, that's the whole point. See, in Python, values is the king. It's not the type. From the value, the type is inferred from the value. So what are the values of a Boolean? Use that. I want you to do, because you will get a hang of it. Yeah. Write something like g equal to some value you need to write, and so that g becomes a Boolean. So if you have not done, I will just give you the answer. What issues you are getting, you can tell me that also. So it is TRU, capital true. So it's a bool. It's a Boolean type, but it's a capital T is very important here. So when you see anything in green, you can understand, and that too in bold. It's a Python defined keyword. Okay, bold. True and false. These are the values. Okay, so remember this point. Some people put it like this, and that's a mistake. It becomes a string. Okay.
Sir,
Yeah.
Like we were considering in a single thing intent float, like like we were taking something 3 plus string of something, so it was giving answer. So how will we take int and bool value together?
So you mean it is 3 plus string? This is what you're trying to tell?
Yeah. I mean, so similarly, how will we take int and bool together? I mean, we can do the same like we are doing for the this one 3 plus high.
Well, it is going to give you error. Why? Because Python doesn't allow you. You need to. So this operation can be done between string and string only. So you need to convert it to string. It
Oh
has to
yeah,
be
yeah.
converted to string first. So
Okay.
whereas when you say 45 plus true, right? This one,
Yes, sir.
this will be a 46. Because true, when you convert a true to integer, so what it will try to do is try to convert to a higher level of data type. Okay, it will try to convert to higher level of data type. So true boolean would be converted to integer
That will be one actually.
1, so it will get added like that.
Okay, yes, sir. So 45 plus false will be 45 only because false will be 0.
Yeah, right.
So we don't have to change here into int this boolean value for 45 like we did in string.
Yeah.
It
Yes.
will automatically will take 1.
Yeah, it will automatically be converted to 1 because integer can be added to integer only or a float as well. So when you use float, the integer is converted to float and then added. So let's say 4 plus 6.7. The 4 will be made 4.0 plus 6.7. That will give you 10.7.
Okay.
But if it is possible to convert, then only.
Sir, so basically boolean is a class, no, where we are putting the values which are means true or false. Boolean is a
Absolutely.
class.
Yes, right.
Yes.
Everything is a class. String is also a class. Integer is also a class. Float is also a class. Everything. Everything in the Python is a class-based object. Everything is object. Nothing like primitive type in C++ and Python, right? Not Python, Java. So class, when you say class means object or a type. Class also, right? We tell it, right? In the class also. In here also we say, when you say classification means what different categories, right? So here also when we say class means what category this object belongs to. That's the meaning of class.
Yes.
So integer is one category, float is one category, string is another category, shopping cart is another category which a user has to create. Even this is also a category which Python developers have created for us and given to us. I think we need to take a 20 minutes break and then we will come at 12 o'clock and then we will go up to 120. The
Yes. Yes.
sounds good, Rohan, Adarsh, and
Yes, sir.
Sir.
Yes, sir.
so 12 o'clock we'll come and then we'll go up to 120.
Sir,
Okay.
excuse me.
Okay.